Hello, my name is Joshua Tyler, and I know it hasn't been a while since I've uploaded anything educational, but I'm currently getting my master's degree and I'm finishing up my thesis, so allotting time for doing this kind of stuff, which I enjoy, is just not really in the cards right now. But I do have a little bit of time, so I do want to make a quick video. This is something that I was thought experimenting when I saw some video on the Quake 3 algorithm for the fast inverse square root, which was pretty interesting, which got me thinking, okay, what's a fast way to do a square root? And I saw something, it was like, if x equals 1, then y equals 1, and then x equals 2, then y equals 1 plus 3, and then x equals 3, then y equals 1 plus 3 plus 5, where y equals x squared, which is pretty interesting, but to me seems somewhat inefficient. So I was thinking about using the natural logarithm to do it. So if you remember back in your math courses, if you had a calculator that you needed to calculate like log base 3 of something, but you didn't have log base 3 on your calculator, what you would do is the natural log of the output, the natural log of the thing that you wanted to find what the base to some power is, over log base 3 would equal some number where 3 to the x equals y. So here we need to kind of swap this around, where we know what power it was. We know it was some number to some number squared to get this. So let's swap these around, where y is the y is the output equals x. So if we look at it this way, where we take the natural log of our input over log of the number that we want out equals 2. We can then say log of x over 2 equals log of y. And then using Euler's constant, taking each of these to the power, taking Euler's constant to the power of each of these terms, we can kind of free this y up, where you have e to the logarithm of x, natural logarithm of x over 2 equals y. And the reason this works, let's see, equals y. And the reason this works is if you take e to the log x over 2, you can simplify this. So if e to the a times b equals e to the a to the power of b. So what you can say is e to the log of x over 2 equals e to the log of x to the power of 2, or over to the power of 1/2, and this turns into x, and that turns into the square root of x. So we know that this is a way e to the log of x over 2 equals square root of x. And the reason that this is actually a really powerful method, or a really efficient method, is because in most computers, natural logarithms are stored in lookup tables and exponentials, Euler's constant, or things. Euler's constant taken to the power of numbers is stored in lookup tables, because these are the natural logarithm and Euler's constant to a power is an infinite series. So it would take forever to calculate them. So what they do is they go ahead and calculate these numbers. They go ahead and pre-calculate these numbers to a really small error level, or a really large number of terms summed, and then they save them and they store them on the chip as a lookup table. So then it's like, okay, so like I've taken the log, I've taken the logarithm of 2. Okay, so I look up where's 2. Okay, 2. Okay, this is the output, and then done. It returns it. So this is only 3 steps, really. So step 1 is look up logarithm of x and then you divide result 3. 3, then you just look up, I'll say result of number 1. And then we'll look up result of number 2. And we're done. Like, well, I mean, if you want to add 4, you return of number 3. And that's pretty much it. You're done. So in 3 steps on the computer, you have calculated you have calculated the square root of a number. And then if you want to take it one step further, you can add a 5th step in between. So if you want to do inverse square root, square root, you can look up um, log of x to divide result of number 1, divide step 1 by 2, 3, look up Euler's constant to the power of the result of 2, and then you do divide 1 by result of number 3, and then you return 4. So in 4 steps, well, essentially in 5 steps, you've done the inverse square root, and then in 4 steps, you've done the square root using the natural logarithm. All right, that's all for now. I will see you when I do.